And we have quite a lot of presentations and very interesting ones, and also a lot of speakers. So I propose really to start now and give you the floor immediately to you, Gustavo Omen, from Meaningful Data on VTL.
Yeah. 1, 2? Okay, thank you very much. So I have a first rhetorical question, which is, what lies in between something which is, theoretically possible and something which is adopted and used by thousands, hundreds of thousands, millions, whatever? What lies in this space between the two things? In my perspective, is a product with great user experience. It's often what lies in between. The industry is filled with examples of things that are theoretically good, but never realize their full potential, which is not what we want to happen with VTL and STMX, of course, and that's why we are here, all of us. So we want to propose a VTL-centric VTL experience. VTL-centric meaning that your only problem should be writing your VTL transformations and validations. And we should take care of every other problem. In the past, we used to say that we want to be friendly to business users, but actually, I think that it's not right. I mean, we want to, but in practice, we want to be friendly with every user. And if we can be friends with the business users, which are often the hardest ones, we can probably win the hearts of everybody, which is the end goal. The VTL suite is a commercial product that builds on top of the VTL engine. The VTL engine is an open source library that we publish and maintain, that you can find and download on GitHub, and it is the base of our enterprise-grade product, the VTL suite. Very quickly, to explain what the VTL suite is about, it is a web-based application that contains an opinionated VTL IDE. This means you cannot put Python here, you cannot put Java here, nor assembly, nor COBOL. You can only write VTL here. It is their way. And because it is that way, it brings the advantages of VTL. But before that, something that probably you're going to hate, it even has a manual built into the product. Nobody likes to read the manual. We think that the product is easy enough to use so that usually we don't have to read the manual, but in case it's necessary, you don't even have to go to another window. It is there with you. So advantages of having an opinionated IDE where you cannot write Python, Java, or COBOL is that it has built-in debugging. You don't have to put print in your code because every transformation that you do, which generates a temporary data set, can be inspected directly. You can check the data structure, you can check the resulting data points, you can see if it makes sense. It also has built-in version control. You don't have to learn Git, but still, you can work with version control. It's very easy, and the changes that you do to the project are very easy to audit, so you don't lose track of what you're doing. Of course, you can easily back up and restore your projects. You can use users and teams. You can have several users collaborating in the same project, but you can also isolate users so that there is no interference across different projects. And finally, to summarize what the VTL suite offers, it offers this studio where people develop VTL projects, people develop, people debug, people submit for execution, and then it has an execution environment that can be invoked by any data pipeline because it has a REST API, which is actually how you integrate the VTL suite into whatever data pipelines already exist in your institution. It's with a standard REST API. You invoke the same VTL transformations that you have written in the studio, which we call the VTL playground. So this is a summary. Now the challenge today is to try to push the ambition and go a little bit into the data science field. Is anybody familiar with this expression, QIC? Please raise your hand. One person, two, three, four, almost everybody. So everybody knows that this means know your column. And being in Rome, I guess that most of the audience is familiar with columns. So let's have a look at some columns. The particular columns related to the real estate market in Europe. For example, we could be interested in exploring the stock of a particular city in Portugal, chosen randomly, Lisbon, and see an histogram for the distribution of values. Looks kind of funny, but even funnier is the distribution of transaction prices. Why do we have this bimodal distribution that we were able to find with 3 clicks? This is the question. The answers are for later. We can do further things. For example, relating columns with other columns. We just have to turn them around. So for example, we might be interested in understanding how the yearly prices, the yearly deflated prices, so that they are comparable, of this particular city have evolved over time. We see here, because the data is reported quarterly, that we have vertical data. So for every year, you see 4 dots. That's fine, because with this we can see the interquarterly variance. But if you want to get rid of it, you can simply transform this into an average with 2 more clicks, and then you have a time series of the average done for every year over the quarters. Did you know that the relative variation of the deflated transaction price is correlated with the logarithm of the supply to demand ratio? Probably you didn't know, but this is another fact that is easy to find. The correlation would be nice if it weren't for the outliers, but you can also very easily remove the outliers and find the real correlation. But you can also parameterize your code, by choosing the particular city or choosing the base year, the year where the interesting data begins, etc. This is done with VTL scalars. But maybe, the housing market is too depressive and we should talk macroeconomics. So in this case, we have some simple examples from Eurostat with the real GDP series. We simply have to go to the Eurostat website, copy the URL for the data structure in STMX format, and then do the same thing for the data points. We copy the URL for the data points. We paste both into the VTL suite, and voila, we have the data. It's very easy. I love STMX. I love that it can be integrated with VTL, of course. And, with 4 simple lines of VTL, we can, from the data, understand that, for example, the real GDP of Portugal and Spain are very deeply correlated. So you have an R squared of more than 0.9 in this case. Maybe we could think that this happens for all the countries in Europe. Not true. If you compare, for example, Spain and Italy, the correlation is very, very different. We are not going to discuss this because we don't have time, but the point is that it is extremely easy to find this kind of relationship in the interface that is offered by the VTL suite. So what else? Tell me, what else do we need? What do you need? A correlation ranking? You give one column and it gives you the ranking of correlation of all the other columns? Or do you want the full correlation matrix? Or do you need the new Chatterjee correlation coefficient that works in nonlinear relationships? Or maybe do you need to process data sets that are larger than the memory of your server? Actually, we are just beginning this journey of exploring the applications of VTL to data science, so we don't have all the answers. I invite you to visit our booth and tell us what you need. If you have more questions, they're all very welcome. Thank you very much.
Thank you, Bruno. Okay, Today, we will present a new feature of the VTL engine and editor, that is the engine and editor that we have developed at the Bank of Italy for working with VTL. It's something that we have been working in the last years, and I don't want to spend words on that because we presented many times. But today, I will focus on a particular feature that we developed during this year, because in 2024, with the VTL task force, we worked on a complete revamp of the VTL documentation. We moved from a Word PDF format to an HTML format that is continuously built from Markdown files. And in particular, we decided to develop the examples of the operators that are present in the reference manual that you see. One of the examples is on the right part of the slide, with very granular and technical files like CSVs, JSON files, and of course VTL call. What you see on the right is the rendering, the HTML rendering, but this rendering is built, compiled from this kind of files. Why did we do this? We did it because we wanted to leverage these examples in the manual as part of a test suite. So the developers of engines could use these files as part of their testing. This way they could ensure that their engines were compliant with the standard, with the examples that were explained in the manual. On the other hand, we were also sure that the example worked, because if a developer told us that his engine gave different results, we could probably spot an error in the manual or in the engine. So it was a win-win. At the second time, we realized that these examples, these files, could also be used for this new feature that we have developed in the engine that we called the VTL mode. So when you open the engine, we have already packed inside of it, just switching from normal mode to demo mode, all the examples that are available in the manual. We do it at build time. So every time we make a new release, we update the example, taking them from GitHub. So this way, the engine is immediately usable as a demo environment where you have all the examples that are in the manual, you have all the input data and metadata, and you have all the output data and metadata. So it's like if you had a live manual that you can interact with in very granular and detailed way. And also, it is not locked. So you can also change the code of the examples, and you can change everything because you are in an editor, in a VTL editor. So you can try and test examples that are not covered by the manual, because in many cases, it's not possible to give all the possible uses of an operator. It's quite difficult, not possible in this case. And now Valentino will show you in more detail how it works.
So let's have a look to the implementation of this new feature. After we start VTL Studio from an R session, we are presented with a main screen, and the demo mode is simply activated by a simple switch. Once you toggle the switch, you are presented with an ontology of VTL operators, and these operators that are listed in the two checkboxes can also have also on the left a link to the actual page of the documentation. So if you click the arrow, you can open the documentation page of the examples where you can, of the operator, where you can look at the examples and see if the results you get are in fact the same. So once you open up the examples for one particular operator, you are presented with a code editor, a simple code editor, and you can go on and compile and then browse the results. For example, you can look at the structure of the result. That should be the same, of course, and also look at the actual data that were produced by the engine. So once you've done that, you are not finished, because in fact the other important characteristic is that the examples are not fixed in stone. So you could add or describe data that you have, for example, using an additional module of the editor that is a JSON editor, dictionary editor, or you can attach any data from, example, from an SDMX registry. Once you've done that, you go back to the editor and you can change the code as much as you like. In this example, we added one dataset from the Pacific data community, and we tested that operator on that real data. So you can go on, compile, look at how the change in the example affected your code, and you are free to experiment, for example, during a normal training session.
Just a last word. The VTL Studio that you have seen in these slides is a Shiny R app. So Shiny is the web technology of R, and so it is possible also to use it not only in a standalone mode, as Valentino was showing from our studio and all, but you could also install the Shiny app in your Shiny server, or it could be also installed in Shiny apps. For example, we did it. And so anybody can go and browse this live demo from a server. Thanks.
So let me turn now to Francesco Rizzo, so from ISTAT. Many thanks.
Yes.
You can sit here if you prefer.
Good afternoon, everybody. First of all, I would like to thank my colleagues Alessio Cardacino and Carlo Boselli, because they contributed to this presentation. The main aim of this presentation is to explain how the SDMX toolkit released by National Statistical Institute of Italy, with its user-centric design, can hide the technical complexity of SDMX and facilitate SDMX implementations. The development of the toolkit started in 2016 and had since been continuously enhanced based on feedback that we received by users and organizations. After a recap of the core features that can be applied to both technical and statistical business processes, the presentation will focus on the evolution of the toolkit into an advanced platform ideal for data engineers, data architects, and data analysts. The SDMX toolkit is an open source modular solution for collecting, transforming, processing, reporting, and dissemination data and the metadata using the SDMX standard. It helps overcome common barriers such as technical complexity and limited expertise, making implementation aligned with modern data practices. The Meta Manager features allow users to govern SDMX structure metadata as an SDMX registry, and the Data Manager features streamline the activities requested to create database compliant with the SDMX data cube model, as well as to validate and ingest data sets from both SDMX and non-SDMX data sources. SDMX data flows can be published through intuitive slice and dice operations, and SDMX data files can be easily generated for reporting to international organizations. A user-friendly editor is available to support the compilation of both SDMix reference metadata and digital catalogs in accordance with the W3C data catalog vocabulary. While SDMix and CCAN APIs allows machine-to-machine access, the data browser web application empower users to explore local and remote SDMix data source, generate visualizations in table, chart, and maps, and perform statistical analysis using also interactive dashboards, and support decision-making with harmonized data. Before commenting this slide, I would like to thank the colleagues of African Development Bank, because some of these features were developed as part of Open Data Portal 2.0 that is used within the African Information Highway project. The toolkit has been evolving into powerful enable for automation, allowing the standardization and industrialization of statistical business processes. The Easy SDMX feature, which hides completely the complexity of SDMX, allows users without any SDMX skill to manage structural metadata and data using Excel templates. Through a plugin manager, now the toolkit allows the incorporation of plugins developed by third parties. Istat has already developed plugins that support data conversion from Excel, PIX, and CS Pro, and with the packet support in the pipeline, as well as reference metadata conversion. The SDMix pull request enables scheduled jobs to automate data acquisition from files and APIs, minimizing manual effort. Transformation rules can be defined using a formula builder or using directly SQL language with the support for fixed and calculated field and transcodings. These rules are then embedded into the ingestion process. Advanced processing features support aggregation and derivation of new variables. For example, it's possible to derive a new GDP per capita variable using GDP and population variables, even if they are stored in different data cubes. Structure and semantic mappings make it possible to reshape datasets and even integrate non-SDMX legacy databases. Using the mapping handler feature, it is easy to map data structure definitions created by international organizations. Built for performance and scalability in order to efficiently handle massive datasets, the toolkit implements decoupling machine-to-machine access from web UI access, scheduling large-scale data loading or scheduling data transfers across different environments, caching of data and metadata to improve response time in the data browser. Tests in instant dissemination environment, we used databases with over 10 billion data points and data cubes with more than 100 million data points. An AI backbone was recently developed. It connects directly to SDMX APIs, retrieving both structural and content-related metadata essential for constructing relevant and context-aware data products. Accept requests from a chatbot, interface with OpenAI service to interpret and generate natural language responses. Through chatbots integrated into the data browser, the user can search for the most relevant datasets, preview visualization tailored to their requests, look up explanation of statistical terms, customize data visualization, generate trend analysis, and describe tables, charts, and maps in natural language. If you want, you can play with this chatbot if you access directly to the data browser exposed by ISTAT for the dissemination of data warehouse. Conclusions. The toolkit hides much of the complexity of SDMX standard, providing an intuitive environment where a user can work through visual interface, guided configuration, and pre-built components without needing to master the SDMX technical specifications. This dramatically lowered the entry barrier, especially for institutions with limited SDMX expertise or IT support. The new strategy embraces emerging capabilities in data engineering, data architecture, data analysis. By aligning with these disciplines, the toolkit supports now more robust data pipelines, clear metadata governance, and the ability to design interoperable, scalable infrastructure. The integration of AI technologies enables data users to search and customize data set visualization while interacting with a human like virtual expert assistant. For those of you that are interested in more information, my colleagues and I will be happy to answer you also during the breaks in our exhibition space. Thank you very much.
So many thanks, Francesco. Now we have to move into a second round of presentations, and then we open for Q&A. So please, thank you very much. No, but please, just that's my favorite. Okay, so thanks to the previous presenters, we are really on time, so we have a lot of time and a lot of presentations now. And let me start now with Jonathan Challenger from the OECD on Stat Suite. Jonathan?
Slight technical problem and personal problem trying to get this button to work. So anyway, I'm here. So I'm going to talk about the statistical information collaboration community over a little more than 10 minutes, I believe, because one presentation dropped out. So we have maybe 12 minutes each. So yeah, when I talk about the SICC for short, so this is really about the community, and we as a community, and you saw this actually, the power of that on the stage in the previous session. Every one of those presenters actually was either directly a member or interacting with our community in a way. So you can see how this is sort of leading to this co-investment, co-innovation sort of model that we try to instill. And this is really about coming together and solving these common problems together as well. One of those is around tools and what we developed together is the .stat suite as a tool, and this is, as you can see, is really being like leveraged and used, more than 50 instances now around the globe, and many more in the works. And this is contributing a large part to the implementation and the adoption of XDMX at the core. And I'll explain a bit about this later. And you will see a number of use cases that will be presented tomorrow morning as well during the two sessions on use cases and success stories. In addition to that, capacity building is very important to us, and we developed the .stat Academy. And this is enabling organizations to build skills in data modeling, but also the usage and application of the tools. You can see here a number of certified and registered users we have now. And again, everything we do is open. So this is open and available. Go and create an account, and you can see the vast array of resources that we have available. And I'll talk more about this tomorrow afternoon in the panel discussion that will close day 2. We're coming to the end of one cycle, and we're moving to the next cycle in our community sort of evolution. And sorry. Yeah, so as we move forward into our new cycle, this pyramid in large parts remains the same. So we're still working towards these common goals of building an inclusive data ecosystem, modernizing the life cycle, and making data more accessible. We heard a lot about this, making data more accessible, and especially through AI is going to be very important as we move forward. In addition, our sort of foundations here, as you can see, are really remaining the same. One addition, and this is something which, as I mentioned in the previous slide, which is around .stat Academy, we've built this experience over the last 3 years, and building knowledge, or open knowledge building, I should say, is really a big part and a foundation of and how we see where we go in the future. To ensure we continue to do this, and how we also allow organizations and data producers to really become or make their data AI ready as well, even more relevant. And this is again another important part. So continuing to stretch what we do, and as I mentioned, this AI sort of enabled and enabling AI is very important on our sort of next cycle. In addition, and it's not been mentioned so much, there was a few sort of introductions to it, but user research is vital. So yes, we can do all this nice shiny things and produce AI, and we can continue to sort of produce data, but unless we really understand who our users are, how they use that data, what they want to do with it, etc., then we're really not going to sort of get it right. So we're mainstreaming user research. And when I talk about this, it's about the techniques that we use here. So UX analytics, usability testing, surveys, etc., interviews, and to understand and really support this user-centered design of products. So this is really important for us as we move forward into our next phase to build on what we've learned and try to improve here. And really drawing on this sort of evidence base, and we're all stats agencies, we're all producing statistics, so it's important that we actually use that evidence also into producing what we build as tools. And this is all underpinned also by our user research task force, which will really help us drive this, and mandated to drive this forward. Also, as I said, there's a lot of talk about AI, but we need to bring these together also in terms of like understanding our users, and combining that AI and that UX together can allow us to sort of have that loop and that feedback loop. We saw it with the InLook guys that were presenting, and this will allow us to close that gap, that cognitive gap between the sort of data producers and the data users, to understand better and produce better products for them. Also, .stat Suite, I mean, to be able to deliver in an open source way and efficiently, and both cost and also in time, is really, we've underpinned this with a DevSecOps operation. So this is allowing us to sort of put in place, a robust system that allows us to continuously deliver. And over the last 5 years, you've seen we +1 release per month, and we are in discussions with the community now to move towards a continuous release train. This is quite a complex slide. I'm not asking you to read it all. It's just, I'll mention a few things here, and it's just to demonstrate that DevSecOps doesn't come lightly. So it's something that really is a big investment, and it's a big investment that we've made, and I think that this has served us well. Automated functional test, automated performance test, security tests, and focusing on web accessibility are really helping us to achieve this, and it will continue to help us achieve this as we move forward into our next phase of our cycle. So, .stat Suite as a platform, component-based, built on XDMX, allows you to efficiently manage your data lifecycle or your data across your lifecycle. It's underpinned by .stat Core, which is using currently Eurostat's XDMX web services. It's native XDMX, and it exposes an API which allows to consume through a Solar search engine, which is open source. Also the Data Explorer, where you can explore all this data and visualize this data. But also it can allow you to index potentially any XDMX endpoint through the Solar search engine. The back office, so the Data Lifecycle Manager, is allowing you to efficiently manage that from a data producer's side, integrating with open source tools like FMR and FMR Workbench, also with common tools such as Excel, which a lot of statisticians still use in their daily work, and also automating more pipelines with R and Python, and even working with visualization tools and like Power BI and ArcGIS with geospatial data. So as we move forward into our next cycle, we're already in a support of XDMX3, but we're looking to move forward with full support of here. So more efficient management of data and metadata, and this is really around sort of helping us to understand better the attributes and also more flexible management of structural metadata, as I said, and especially codeless. So codeless here is about versioning. With XDMX3, you've got, and you'll see this, and hopefully some of you will get to practice this on the capacity building around supporting extended codeless or codeless inheritance, and also support of processing metadata to really have this sort of more metadata-driven approach across the life cycle to more automation as well. And again, looking towards improving the performance, especially around very large data tables and efficient pagination of that. What's next beyond XDMX3 for .stat? Well, we talked a lot about AI already today, and we're no different in our community, and you saw this in some of the presentations earlier today, and we're looking to improve the data accessibility, especially on having this conversational sort of data explorer, also working with our IMF colleagues on this global statistics commons with StatGTP integration. Also looking towards hyper cloud scalability as well, more and more data, and we're moving from 1 billion observations to 10 billion observations and beyond, and really to scale up to high performance. Then next generation XDMX data modeling, and again, this includes elements of AI, and we'll have a side event, a quick plug on our side event tomorrow afternoon. Please stay in here after the plenary where we will discuss this in more details, and you can find out more about the future of XDMX data modeling. And to really move towards this sort of metadata-driven automation process as well, introducing XDMX calculation orchestration, sort of an engine, if you like, behind, and to allow for these pipelines to really become efficient. Also integrating AI agents in this process as well will be very important for us. As a community, our strategic value is we're open source, so both as a product, but both also as a practice. We're open knowledge, so we share, but we also help to build knowledge. And this also leads to open innovation, so and underpinned by XDMX, and in the future it will be AI very much at the heart of that. So I invite you to come and join. Also, please come and visit the booth. I'm sharing with XDMX IO colleagues out in the breaks. Come and have a chat and discover more. And thank you for your attention.
Many thanks, Jonathan. So let's move to the second presentation from Jonas Rieger and Benjamin Keller from HMS. So you start. And Brian is joining us also.
Perfect. Yeah. Thanks, Jonathan. Thanks, everybody. Honored to be here speaking with you today, both in presence or online. Hope that you've enjoyed the session so far. So there are a great many recommendations this morning on work in progress and on the way forward. We heard about the need for an integrated approach with interoperable tools, the need for collaboration, not competition, and the shortage of resources and expertise. SDMX.io is not a tool. We'll make that clear right from the start. I won't repeat everything. I hope you caught enough. But SDMX.io is an ecosystem based on a partnership model. So the partners include SDMX sponsors, private sector organizations, and public sector organizations such as central banks, national stats offices. More partners, many signed up already, discussions ongoing with others. The ecosystem consists of a wide range of trusted open source tools. Many of the tools that have been presented here today or will be presented this week are either already in the ecosystem or, again, in discussion to join. If you wish to become a partner or have your tools onboarded, please reach out. Our contact information is on the website. SDMX.io is use case focused, so it's looking at what problems. Trying to keep this a couple minutes, so I can talk too long sometimes. It's use case focused, and it's trying to address your problems in a manner that makes sense to you by bringing some of these tools together in an integrated way and showing how to do various statistical activities. So we're regularly onboarding new partners and tools, and I'm here today, and I'm very excited to be here with, I think, a new tool, SDMX Lab, which I think has the potential to be a real game changer. Over to you guys.
Yeah, thank you very much. Thank you very much, Brian, for setting the scene. So I'm Benjamin from HMS. I won't talk about AI today, sorry for that. I want to talk about the new member of the SDMX.io family, which is the SDMX Lab. So let me start with a very simple question. Why did we start implementing the lab beginning of this year? Why does the lab exist? And the answer is fairly simple. We wanted to have an easy system for proof of concepts and hands-on learning. So why that? I think if you are using SDMX in a day-to-day business, you have the right IT infrastructure, you have the right IT software set up supporting you in that operations. So you need IT tooling to support SDMX. And if you are now very new to SDMX, as an individual or as an organization, you also need IT infrastructure. You need tooling to really get started with SDMX. And if you start with SDMX on that and need these IT systems takes time to set up and they need budget. And this might slow you down so that you cannot really get started with SDMX. So that was the first reason for the lab. The second reason is that we wanted to have hands-on learning. So if you're new to SDMX and want to try something out, even if you're experienced and want to try out, I don't know, the newest features in FMR.StatSuite or in SDMX 3.1, One, you need something like an isolated environment separate from your production systems to try things out. And if you're a trainer and want to give live hands-on sessions on SDMX, you don't want to set up the server tools on each of the participants' laptops. So you need something like a system where people can follow your instructions from the PowerPoint presentation. So that were the reasons, summary, that we have an easy system for proof of concepts and live learning. So now, what is the lab? So the lab bundles prominent open source tools from SDMX in a cloud-based environment. So as a user, you get your personal environment, which does not interfere with other systems like a production system or with other environments. It's isolated, so you can play around, try things, test new things, explore things, and trainers can give each participant an instance so they can live follow the instructions in their own instance. And the cool thing is, it's cloud-based, so you just need an URL, username, password, then you can log in and directly interact with the tools. So you have no setup, no installation, you don't need to worry about anything. And the clue is, it's open source, so it will be released, or it is released in SDMX.io. It's free to use for you, and it's owned by the BIS. And now Jonas will take on and show you a live product demo of the lab.
Thanks. Yeah, so say you requested a lab, you got your link, you got a username and a password, and you just open your browser, enter the link, then you enter the credentials, see it live here. Then you have to accept the service level agreement by ticking the boxes and continue, and then you're ready to go. This side is, we call it the cockpit. It shows all available tools in your lab instance. So we can have a look into them. So we have the Fusion metadata registry included. You just click on the link, it opens, and this is your personal instance where only you can edit or create things. We also have the .stat suite. You can also click on it, it just opens. And similarly, we also have the reference infrastructure. All of these tools are ready to use, so they are pre-configured. We also provide some integrations. So the FMR Excel add-in Fusion Excel is supported with some hints on the configuration. The .stat DLM Excel add-in is supported. And for developers, we have some Python notebooks ready with PySDMX so that you can access the APIs of the tools. And really focusing on the learning or POC use case, one of my favorite features is the reset button. So if you scroll down in the cockpit, you can just with one click reset everything and start from a clean state and either try to reproduce what you achieved or start from scratch if it didn't work out. As Benjamin said, we started with the active development in January, and we're still under active development. We've already supported training events with up to 40 participants with the features you see here, so FMR.stat, RI, the notebook access. But we also have some key features on our roadmap to come. So we want to streamline the sign-up procedure. Currently, it's based on emails if you want to have an individual instance, but we want to have a process that new instances are ready within minutes. We want to provide use case-based labs, so predefined metadata and data for specific application areas and use cases that you can load into your lab with one click. And collaboration features so that you can work together with others in one lab instance to co-create SDMX structures. We are also evaluating whether and how the lab could support bridging the gap between POCs and full production systems. This could mean that you not only use the lab for POCs and learning environments, but that you could also have an out-of-the-box solution ready when you don't have a productive system yet. We are very interested in your view on this. And lastly, we would like to announce that the lab will be used during the capacity building on Thursday and Friday, so each participant will get his or her lab instance there. On that matter, we would like to welcome you at our booth if you're interested in the lab or have any questions on registering or setting it up. You can also find further information on the lab in general on SDMX.io. So with that, I say thank you very much for listening, and maybe see you either at our booth or during the capacity building on Thursday and Friday. Thank you.
So thanks. Timing is perfect, despite that you had 3 people speaking. So congratulations. The last presentation is from the ECB, and it's you, Ole Sørensen, together with Slatina Hofmeister and Gabor Horvat. But only you will be speaking today.
Yes, my 2 colleagues have been involved in this presentation also, but we just keep it with me presenting the result of this. So I will be talking about the ECB search engine for the EDP, the ECB data portal. It's a search engine that uses the open search from AWS, so it's Elasticsearch. And the input is SDMX metadata on time series and sequence level. This has been used for a period of time, and now we are seeing that we have some issues with the results. We have 3 main pain points related to the search identified. And one of them is that the information overload. We have around 4 million series disseminated in the portal, and this number of time series increases every, month, 6 months. So the search returns too many series, and it's difficult to narrow down the results. Also, the metadata quality is a bit of an issue because it's not always descriptive enough. And for this reason, it's really essential to making a better ranking of the search from the users. I don't know, how does the search engine work? For this group of people, I'm not sure this is so relevant, but I think most of you know. But we need some metadata, we need to index the metadata, and then we need to rank the metadata. It's kind of a ground principle for the search engines to make it work. And if we have an example where we will search for butter price, then butter would be indexed, price was probably not, because price would probably cover too many different time series, but butter would be covered. And in that way, the search engine will faster find the series keys related to butter is used as an index. So we had 3 main objectives for trying to improve the search engine, and one of them was to just look into the current queries we have, see if we could improve them, making some of the search templates more related to different dataset types. So in principle, it was just about boosting the important metadata and choosing the optimal weight of these metadata. Another experiment was to apply some AI-driven metadata tags. So we will run them through different models, like clustering algorithms like the k-means, and other different models for pattern detection for the metadata, and then to boost the data for a more intelligent search. So in principle, it's like just adding some more tags to the series keys, and then adding them as AI tags. And the third experiment was to advance the query expansion using some optimized templates with stop word list, synonym files, etc. And then in principle, this is more about adding the tags or the index search words for this specific series keys. So adding it more specific in this way. The current accuracy for the model we have, before we try to expand the or do the experiments, was that we had around 60% of correct results. So it's a very small sample. It's only 123 search items, but it's just to give an idea where we were and see if the experiments we did was, I mean, it was easier to test them and check the real outcome of these experiments. But as you see here, we have, I mean, we want to accomplish that we have the search results within the first 4 positions. But in this case, we either have 31 in no response and 17 not in top 5. So what we did now, and maybe, I don't know, 1 or 2 maybe now see that I'm jumping to experiment 2, because experiment 8, we didn't really gain anything with that. So just trying to improve the search and the templates we had already did not really give anything. So experiment 2 was the one where we added AI tags and see if that could improve the search. And it did improve. You can see here the first position with the current is 57, and with the first position with the AI tags is 73, but we still have some results that give no response or not in top 5. So it's not really efficient enough. So experiment 2 and 3 combined, which then is the AI tags, and then the adding the tags to point to specific series keys. We then gained 100%. But the result you see here now, the headline experiment 2 and 3 combined, but in principle, the result you see here is actually only the experiment 3 with the 111 in first position. But if you combine it with the AI tags, we actually reached 115. And I think the second position came in with 6 and the third position 2. So it was a bit better combining it also with the AI tags. So the conclusion and next steps for us now is that it's for sure, even though it's a very small sample of search items, it shows us that this is the right direction. So we will now try to include this in a expansion of the EDP 2.0 that will start later this year, beginning of next year, to see if we can improve it more and then making more sophisticated queries. Yes, that was it. Thank you very much.
Okay, so many thanks. So now we have almost half an hour for questions and discussions. The mic here, Marco.
Hi, hello. So after this good and presentation of several tools, wonderful tools, wonderful features, well, if you allow me, I would like to take a kind of more provocative approach, slightly. Bruno Tissot this morning was wondering if we are still living a kind of separation between IT people who develop wonderful tools and content providers who create metadata and content. Well, I want to reassure him that this was exactly our starting point 24 years ago, in 2001, where 2 of the 4 initial pilot projects were about content, the metadata common vocabulary and the MF metadata repositories. Today we heard that data modeling as the mix are ready to be consumed by users, by AI agents, but if structural metadata are unambiguous, clear, and descriptive. I took it from one of the slides of the colleague from the MF, I think. I would add also reference metadata because some of the information is stored separately from data. In other words, if I can rephrase it slightly, we have powerful tools and with our colleagues at Eurostat. I hear my friend Francesco Rizzo, Nadezhda Vlahova, Stratos Nikoloudis, they know what I'm talking about because we have done, pardon, they have done a big work for structuring the SDMX reference infrastructure, web services, and all these things. Now we have a variety of tools. But if metadata are not equally good, then the results don't match the expected level of quality. Garbage in, garbage out. Now the question are we getting closer to the objective, or we are still in that situation? Please tell me it's not true, because that would be horrible. We might have wasted 24 years of work. So I hope we are not yet at that level. Second, what should be, for those who have management responsibilities, what should be our next steps and our next priorities to move ahead with SDMX, provided we are not yet at the level of 24 years ago?
Other questions or provocative statements? Yeah, please.
Thank you very much. Yeah, actually, I wanted to have a provocative question, which is, do the tools actually really need to hide SDMX complexity? So do you agree with that? And so does it mean that the tool will solve all our problems? Thank you.
Okay. Other questions? Please. It's a question for the others. It's not a question for yourself.
Who is it for? I volunteer to answer on behalf of the users that are not SDMX experts, but who still have the ambition, to look, find, and work with data sets made of public information. So for this particular enormous population, which is much bigger than the users who are SDMX experts, I would say that the answer is yes. We should have tools that abstract the complexity so that the information, public, high-quality, curated information, is available for a general audience. You have seen a specific example of importing SDMX data structure and SDMX data. It is a particular case that is aimed at users who are not SDMX experts, but they want to transform the data with VTL and do whatever explorations they want. So in this particular case, that represents a large amount of potential users. I think it's yes, and we should have the ambition to make the data more available for everybody. And SDMX is a good tool if we use it in that way, if we think about the user experience. Thank you.
Thank you. And on the point by Marco, you want also to react on your view on the quality of the metadata that is used in all these processes?
I absolutely agree that we need to harmonize, we need to be consistent, and we need to be descriptive. I applaud, I agree, and let's go for it. Absolutely. Because that's part of making it easier for everybody to understand the data. We lose too much time looking for the data, and our budget of time is finite. So the time that we use looking for the data is not time that we can use processing the data, analyzing, and trying to answer the questions that the data brings. So absolutely yes.
So we take another question, and then I will turn also to the panelists so that you can react. So let's take a few more. So first.
Eric Anvar from OECD. I would like to perhaps complement the point that were made. I guess when we come to complexity of SDMX, there is two aspects to that. One is for the users of the data, and obviously that should be very simple for them. We see that soon it will be hidden behind an MCP anyway and an AI, and so they will not even know that this is SDMX. That's one part of the question. And the other part is more for the data producers, and so how to make it easier for them to model data and metadata, and to what extent is the problem really reducible and simplifiable? Because at some point, when you have different teams and you want to harmonize the data across these different teams, there is a degree of complexity in terms of skills and governance that you need to set up in, at least at the level of an organization, if not at the level of an ecosystem. So I guess that's the nexus where we have to resolve in terms of tools, capacity building, governance, and perhaps AI can help. So it's a question.
Yeah, thank you. I want to give response to two of the questions. One, for the question of Jens, I think that it depends on the tool. But definitely I agree with the colleague that for the tools for final users, SDMX has to be hidden. And I don't want to repeat the example of the Wi-Fi that much people in this room probably already heard from me several times, but I hope that one day SDMX will be the Wi-Fi with the statistical data that is there, but we don't know to know the standard to use it, and everybody uses it and connects. So that's the desideratum for a standard. And regarding Marco's question, I think that one of the great values of SDMX is the flexibility in terms of its usage for modeling data. It's a technical standard that allows to very quite easily create structures for accommodating almost any type of statistical data. Perhaps we should start now thinking of adding a new layer that will conspire against this flexibility and will add some rigid definitions, but adding semantics to some of our structures to make it easier for other technologies like AI to understand what we're talking about. Because today, the name of a concept doesn't mean anything. In fact, globally speaking, beyond the guidelines, but it's not in the core of the standard. So this, I think, is perhaps the challenge for the next 24 years, Marco.
Other questions for the next 25 years? Kumar.
Oh, thank you for giving this opportunity. So basically, there are two aspects we are discussing here. One is the dissemination aspects. Most of the speakers talk about the data dissemination using SDMX, and on top of it, you are applying the AI. But my question is about the collection aspects of SDMX. That's a big challenge as far as India is concerned. Collecting the data as a data producer, we can easily convert the data into the SDMX standard. So what is available with us, but collection from the granular level, I mean, from the reporting entity level, that is a big challenge. So far, we are so in some pilot activities. So what are the expected challenges for the collection aspects of SDMX? That's my question. Thank you.
Any other questions? Yes, over there.
Hi. So we talked a bit about VTL before, and I'm just interested, is like anybody actually using it in production? Thank you. Another provocative question.
It's good to be provocative. Well, at the end of the day, so makes lively. Other questions? So you want on VTL, perhaps we can answer this first one, Gustavo, and also our colleagues from Banca d'Italia.
The answer is yes. Unfortunately, I have not reviewed with every customer if we have permission to put names, but one of our customers has precisely presented that in the morning, the National Bank of Belgium. So that is one example that has been made public, and as far as I know, everything is going fine with the project. But you have seen the presentation, so we are very happy that this collaboration exists. And I think that we have everything in place for VTL to be used in production in many other circumstances. I'll be more than happy to answer strategic/technical questions. Thank you.
Many thanks. At the Bank of Italy, you want to comment also on this, because you are a big user of.
I cannot
speak about VTL because actually we do not use VTL in production, but we use a language that is quite similar to VTL and from which VTL was largely inspired. It's called EXL. It's a language. There is Angelo here, maybe he can correct me, but it's more than 15 years that is being used in our statistical data warehouse. The concepts behind that language are pretty much the same. VTL is just, let's say, the open tech of this custom language that we have in the data warehouse. We know it quite well. It has, of course, some limitations, but it serves us quite well since a long time, and it solves lots of problems in terms of statistical production.
Okay, many thanks. So I would like to now open the floor to the panel. So you have several questions that were raised. Let me mention the role of structural metadata, whether we should simplify or not SDMX, the difference between the user experience and the producer's experience. So Jonathan, you want to start? The order of the...
I can maybe answer a few. So yeah, I mean, on the sort of complexity of XDMX, I mean, this is something we always sort of grapple with, and it's not necessarily XDMX that's complex, and this is something Jens says a lot, it's really the data modeling part. So if you want to have harmonized metadata, this is the difficult part. It's not XDMX. XDMX actually provides the tools and easy ways of actually doing this. So we just make that clear. I think not everyone has to be knowledgeable in everything of XDMX either. So it's about like how do we actually empower certain individuals within an organization to build those skills and actually learn those skills. And in the community, you saw what we're doing. At least we're providing capacity building and open capacity building in a more sort of digestible way, simplifying the message and the consumption of that information to be able to ease that or lower the entry barrier to XDMX data modeling. We think we're some way there because we have quite a few, subscriber or enrollments and certifications. And these aren't just people from like, resourced organizations. They are even at the low end of the capacity scale. Tomorrow, in fact, we will discuss this in detail. We have the side event, so I encourage everyone to stay after 5:15 tomorrow in this room, where you will engage you as well to understand a bit more about what you want from data modeling and the next generation of data modeling. And you'll see some nice initiatives that we presented here. So how can we maybe hide some of the sort of difficulties of data modeling and ease that process through the life cycle? And maybe just then building on that around the users. So yes, we have internal users, data producers, and from our community also we are, and as I presented, we are understanding more about what their needs are and including them in that sort of feedback loop, as well as the external users. So trying to bring these two user groups together and understand a bit more about their needs and trying to sort of reduce that gap between them. So the knowledge building, the gap reduction, and hopefully understanding, what their needs are to build better tools and deliver better data through the process.